Section 7.2, we're going to be multiplying and dividing rational expressions. So kind of an extension of what we did in Math 55, just a little harder. Couple options here. What we generally do in Math 55, if I see this fraction times a fraction, is we just multiply those straight across. So 5x over 9 times 3 over x squared, and we go, okay, 5 times 3, 15x, over 9 times x squared is 9x squared. And then at the end, we simplify by going, okay, any common factors here? Well, yeah, 15 and 9 are both divisible by, looks like 3. Makes that 5 over 3. And then we cancel out. This has an x on the top. This has 2 on the bottom. So 1 cancels out with 1, leaving us with just 5 over 3x. And if I saw this question, that's what I would do pretty much every time. I just multiply them together, clean it up, and we're done. There is a second option, and that isn't going to seem necessarily as practical or maybe a little more confusing, but it will matter in just a second. So I want this to make sense because I'm going to show you one where we really need the second option. Second option is whenever I'm multiplying a fraction times a fraction, we're just multiplying the top with the top and the bottom with the bottom. So rather than multiply them together, I'm going to just treat it like one big fraction where I put the 5x times 3 on the top and the 9 times x squared on the bottom. So one fraction over one, 1 over 1 basically. And rather than multiply those together, I'm going to simplify first. So I see, okay, I got a 3 over a 9. That 3 cancels out. This 9 becomes a 3. I cancel out one of the x's with one of the x's. What am I left with on top? 5 over, and on the bottom a 3 and an x. That's a lot more to keep track of, and there's actually a lot more potential mistakes, but that is an option. We can, rather than multiply them together, we can just treat them as one whole fraction and then kind of cross-cancel across the entire fraction. Okay? Why does that matter? Why does that matter? Well, if I look at this question, I do not want to multiply this straight across. I literally would have 6x squared, 2x plus 3y, try to multiply all that together and try to simplify it. I would end up with, just at the beginning, I would end up with, what would it be, like 24x to the 4th plus, a whole mess. And then on the bottom, you would end up with what? 10x squared plus 15xy. And so putting it together, I would then have to try to break this mess back apart to try to cancel things out. And so let's agree that option 1 would really stink in this situation. Not a good choice. Okay, so then what would I do with option 2? Well, I would treat it as one big fraction with 6x squared times 2x plus 3y squared on the top over 2x plus 3y on the bottom times a 5x. And what can I do now is I can start canceling things. I have 2 x's on top, 1 on the bottom, 1 cancels out. And the 6 and the 5 aren't going to do much for me, but this group, I have 2 of them on the top and 1 of them on the bottom. So I can cancel one group with one of these. If you don't like how I did that, you could write this out as, just write it out twice, and when one cancels, I'm left with one of them. Okay? So then what am I left with? Well, 6x times 2x plus 3y all over, I think just a 5. And that's it. You could try to multiply those together, but that's it. There's no use multiplying those together. All we wanted to do was simplify it. All we wanted to do was multiply them together and cancel out the like terms. So rather than put it together, leave it factored and break apart and start canceling across the entire fraction. Here's another good example. Z squared minus 1 over z to the third times 8 over z squared plus 5z plus 4. Let's deal with this again. Do not cancel out these z's. It is so tempting. You're like, I got 2, I got 3, boom, boom. Don't do that, because that z squared minus 1 is stuck in a group. And that z to the third literally just means z times z times z, so don't do that. What are we going to do? Well, we're going to treat this like one big fraction But when I rewrite it, I'm going to go ahead and I'm going to factor anything I can. So you have to start recognizing this is an a squared minus b squared from my previous notes. There's chapter 6 again. So this becomes z minus 1, z plus 1. So anything that's factored, I'm not going to multiply them together. I'm going to leave it factored. And I could put the 8 here. Eventually, it might probably move to the beginning. On the bottom, I've got z to the third. And this trinomial factors. What makes z squared? All right, we're doing, let's see, this one right now. This is a trinomial, factoring into two groups, z times z. What multiplies to make the 4 combines to make the 5. How about 4 and 1? Both positive to make a positive 5. Now, I can't really, once again, I'm not trying to multiply these together. I'm just factoring everything I can and going, does anything cancel? Yeah, there's a group that's the same. This z plus 1 cancels with this z plus 1. So what we're left with on the top, you could put z minus 1 times 8. Generally, we put the coefficient there at the front. So 8 times z minus 1 all over z cubed times z plus 4. Not a simple process, but what we end up with is simpler than what we started with. Less terms, less messiness. We also need to talk about reciprocals. Okay, so when we talk about reciprocal, you have to remember all this means is that the fraction flips. Okay, this is also known as a multiplicative inverse. The idea is you're going to cancel out multiplication. Okay, a over b. If I flip that, becomes b over a. Why do they call this a multiplicative? It sounds all terrifying. Inverse. Well, if I multiply anything times its reciprocal, inverse, they all cancel, leaving us with 1. What about if it's a negative AB? Well, flip it. You could put b over negative a, but keep in mind, we don't keep the negative in the denominator stylistically, so we would write that as negative b over a. Once again, if I were to multiply negative ab times negative b over a, everything would cancel. The negative and negative would make it a positive 1. That's why they call it a multiplicative inverse, because it would cancel out through multiplication. You're canceling out a fraction through multiplication. The reciprocal of negative 8x minus 3 over 5x squared, flip it. So the 5x squared goes to the top, the negative 8x minus 3 on the bottom. I would be okay with that, but chances are what would happen is the homework would want you to deal with this negative in the denominator. Okay. So what we would do is we would factor out, on the top the 5x squared would stay the same. On the bottom we would factor out the negative, making that 8x and that 3 positive. And then we would move that negative to the top to make it negative 5x squared over a positive 8x plus 3. Like I said, in the book they're more concerned about that. If I ask you for reciprocal, just flipping it is fine. What if I have 1 over negative 2? Well, we would flip it and become negative 2 over 1. Now, we wouldn't leave that as negative 2 over 1, right? We would simplify that just to become negative 2. Why do we need the idea of reciprocal? Well, right here. How do we divide by a fraction? Short answer is don't. We don't. We don't divide by fractions. It's way more complicated. This one, technically, we could. This one I can do. What is 4 divided by 2? And on the bottom, 3x squared divided by x. One of the x's cancels. Sweet. Except 99% of the time that won't work. So we need something that does work. How do we divide by a fraction? Don't. What are we going to do? We are going to, instead of dividing by 2 over x, we can multiply by the reciprocal, meaning the second fraction flips. And why would we want to do that? Well, now we get what? 4x over 6x squared, which simplifies top and bottom by 2. Gives us 2 over 3, canceling out one of the x's, 2 over 3x. So 99% of the time you can't divide by a fraction, so don't. What we do is we multiply by the reciprocal, and we end up with an answer way faster and way easier. Let's kick it up a notch. X minus 2 over x plus 3 divided by, I don't know why I have all this on there, sorry, divided by x plus 5 over x squared minus 9. How are we going to divide by that fraction? Don't. We're going to sit there and we're going to change it from division to multiplication, and we're going to take the second fraction and we're going to flip it. By the way, we don't have to make this more work. We need to do something anyway. When we flip, we might as well rewrite rewrite everything factored. Rewrite everything factored. So this x minus 2 doesn't factor, x plus 3 does, the x plus 5 doesn't, but rather than just write x squared minus 9 again, see if I can fix that, sorry, rather than just rewrite this, I'm going to factor it. That's an a squared minus b squared. So it is x and x minus 3 and plus 3. What does that do for me? Well, we just multiplied fractions and they were really easy. How do I multiply fractions? We treat them like one big fraction, and we cancel out any like terms. Well, I have an x plus 3 and an x plus 3, and I believe that's it. So what are we left with on the top? X minus 2, x minus 3, all over x plus 5. Scooting this down. How are we going to divide by this? We're going to multiply by the reciprocal. I encourage you to factor while you do that. Leave anything factored, factor anything further. So as we do this, I'm not going to just rewrite this. Yes, the first one stays the same, y plus 3 over y squared minus y minus 2. But that bottom part, I would stop and go, wait a second, that's a trinomial. It can be factored. What multiplies to make the 2 combines to make a negative 1. We have now kept it the same, but while we're rewriting it, we're factoring. We change it from division to, and we are going to flip. So when I flip, that 2y is going to stay just a 2y on the bottom. But this right here, when I go to rewrite it, I'm going to factor it. What makes y squared? What multiplies to make 3? Combines to make a positive 4. Now I can simplify this by treating it like one big fraction and canceling. Okay? Basically the top all over the bottom. Does anything cancel? I see a y plus 1. The y plus 3's don't cancel this time. Why? They're both on the top. I think that's it. So we're left with, you can write y plus 3 times y plus 3. I'm going to just write y plus 3, since there's 2 of them, squared, all over y minus 2. And I'm okay if you put the 2y at the end, but generally, once again, that 2y by itself, we normally stick that in the front. It wouldn't hurt my feelings if you stuck it at the end, but that's how we would divide by that fraction. So that's it for this section, just multiplying, dividing fractions. A lot of simplifying, a lot of stuff, a lot of factoring. Notice it didn't go away, okay? So if you're really good at that chapter, then this should be very easy for you. If you struggle with that chapter, well, we're going to keep reinforcing it, but get good at it ASAP.